Okay, so what I'm going to show you guys right now is how we classify a polynomial function. I'm going to be using two colors. Make sure you've got the notes in front of you. The first thing we're going to do is to classify by degree. All right, so our degree is over here in this table. Now, we know a degree because a degree is the largest exponent. So let's go ahead and look at the very first examples that we've got down here. So we've got x to the power of 4 there. So that's the highest degree there. X to the power of 4 there. And x to the power of 2. So there are our degrees. So I can start labeling these right now. For this first one, x to the power of 4, that must mean quartic. So this is an example of a quartic polynomial. Next one as well also has a degree to the power of 4, so this must be quartic. The third one has to the power of 2, so it must be called linear. All right, now, our next situation is going to be to classify by the terms. Now, a term is separated by plus or minus. Okay, so it's any math expression that is being separated by plus or minus. So I'm just going to start underlining how many terms I have. In the first one, we got 3x to the power of 4. Then we see a plus, so we start a new term, and then 8. In number 2, x to the power of 4, we see a plus, 5x, then we see a minus, and then a 7. In the third one, we have 7x squared. We see the plus, and then the 8. So we've separated these out by pluses or minuses. Now we just have to count them, and those will tell us whether or not, or they'll tell us exactly how to identify it. So this first one has 2, so it must be a binomial. So the full name of this polynomial is a quartic binomial. Next one has 3, so it is a quartic trinomial. Then in number 3, we've got 2 terms, so it is a linear binomial. All right, so let's go ahead and try some of these last ones. There are some interesting situations that pop up in these. Now I do see x to the power of 4, but we also have a y. Now all of that is a single term because we have no pluses and no minuses. The degree of this one is going to be the 2 exponents added together. So that should be y to the power of 1. So altogether, that's 5. So this needs to be quintic. It is a degree 5 polynomial. Like I said, there's no pluses or minuses, so we only have one term. So this is a monomial. All right, this next one. My biggest degree is a degree 5. So we've got quintic. Next, I've got 3 terms, trinomial. Finally, highest degree on this one. It's kind of tricky because one thing we do not see is some variable to the power of something else. So you can assume that this is x or whatever variable you're using to the power of 0. So this is a to the power of 0 problem. This we would call constant. Okay, when you don't see a variable, that's a constant term. No pluses or minuses, there's only a single term, so monomial. All right, let's move on to the next section. Now, to begin this section, we need to start rearranging these into a descending order, so going highest degree to lowest degree. So what we are focused in on, once again, are those exponents. All right, so that first one, we had a 4. There's a 10 without a variable, so that's a degree 0, x to the power of 0. 5x, we don't see the exponent on the 5x, so that's just a 1. So now to rearrange those in descending order, we start with the 4, so 3x to the power of 4. Next would be the 2, so minus x squared. Now the 1, minus 5x, and then the 10. Okay, so let's go ahead and do that one more time. Look at the degrees. With the 32, there's no variable, so that's just going to be a degree 0. Over here, on the minus 11x, there is an x there, but we don't see its degree, so that's just 1. So put them in order. 5x to the power of 7, minus x to the power of 4, minus 11x plus 32. Now, one thing that it's asking us to do here is to identify something new. They want us to identify coefficients. Now, coefficients are just the numbers that are in front of the variables. These are the numbers that you're multiplying the variable by. So my coefficients here are going to be 3, -1, -5, and 10. Next, it wants those degrees again. So my degrees are just the exponents, which in order are going to be 4, 2, 1, 0. The degree of the entire polynomial is just the highest degree, 4. Okay, and we repeat. So once again, I'm just finding the coefficients, the numbers in front of the variable. So 5, -1, since it was a negative x to the power of 4, we assume that there is a 1 in front, -11, and 32. The degree of the terms, the degrees are the exponents. So in order, 7, 4, 1, 0. The degree of the polynomial, 7. It's just the highest one. Okay. A little bit more, and we're completely done. Now, with this, we are going to be talking about adding and subtracting the polynomials. So far, we've just been discussing classifying them. Now we're going to talk about adding, subtracting, and all of that. Now, what I have here is I've got an f plus g of x. Now, I'm just going to do exactly that. I've got my f, which was a 3x plus 1, and then it says to add g. So, plus g is 4x plus 2. Now I can go ahead and combine my like terms. I've got a 3x and a 4x that will combine into 7x, 1 and 2, which would combine into a positive 3. So 7x plus 3. Similar process follows again when we've got g plus f of x. So I'm simply going to start with my g of x this time, which was 4x plus 2. The f of x, which was 3x plus 1. And combine the like terms. 4x plus 3x is a 7x. 2 plus 1 is 3. Only combining like terms. Like terms will have the same variable to the exact same degree. This time we're going to work with subtraction. You may notice that with the addition, it didn't really make a difference, nor would we expect it to. Adding doesn't really matter where you put it. A 2 plus 3 is the same as a 3 plus 2. So order doesn't matter, and we see that as well even in these more complex functions. So once again, we start with f, and we're going to do minus g. So we've got our 3x plus a 1 minus our 4x plus 2. Now, this is kind of the reason I've been putting these parentheses in the whole time. Because as I subtract g, I need to recognize I'm not just subtracting the 4x in g. I'm subtracting all of g. That means the 4x and it means the 2. So as I combine like terms, I need to keep that in mind. I am doing my 3x minus 4x. 3x minus 4x will be negative x. Okay, and now I am doing my 1 minus a positive 2. 1 minus positive 2, negative 1. All right, switching it up this time, we've got g first. So 4x minus, or sorry, plus a 2. And then minus the f of x, 3x plus 1. So then 4x minus 3x, it's just 1x, or just x. And then 2 minus 1 is a positive 1. So that did change our answer a little bit, whether or not we were doing f minus g or g minus f. All right, these bottom problems do provide a little bit of an extra challenge. So we're going to have our f of x, and there's our g of x. So all of my g's in blue, all of the f's in green. Everywhere I see f, that's where I'm going to replace it with x plus 1. So starting out with this one, x plus 1 plus a 2x minus 3. So x plus 2x, 3x, 1 plus a negative 3, negative 2. Now, I'm actually not going to do this one over here because I already know that rearranging the addition isn't going to change it. F plus g should be the same as g plus f. So we'll get 3x minus 2 again. Next we've got x plus 1. This time we're subtracting 2x minus 3, and here's where things can get confusing. So we still have x minus 2x, so that'll give us a negative x, but now Okay, so that's everything you guys need to be able to do this work. Keep track of that minus when you are subtracting. Remember, it's going to look a lot like distributive property. So just make sure you're careful with that. Okay, thank you.